Hi, I'm going to share some ideas on Spring Framework, mainly about its core modules, resource, validation, Spring Expression Language, aspect-oriented programming, and Bean Post Processor. Resource Spring Resource Interface is located in org.springframework.core.io package for low-level access to resources. It extends the input stream source interface and has these methods. Get input stream, locates and opens the resource returning an input stream. Exist, return boolean indicating whether this resource exists. Is open, returns boolean indicating whether this resource represents a handle with open stream. Get description, returns a description for this resource. Other methods used to obtain a URL or file instance representing the resource. Some resource implementations also implement the writable resource interface. Resource interface implementations can be used as a utility class. Some of the built-in resource implementations. URL resource. It wraps a java.net.url and can be used to access any object that is normally accessible with a URL, such as files, HTTPS, FTP, and others. URL resources have standardized string representations used to indicate one URL resource from another. For example, FTP colon, file colon, and HTTPS colon. Class path resource. This class represents a resource that should be obtained from the class path. It uses either thread context class loader or a given class loader or a given class for loading resources. This implementation supports resolution of resources as java.io.file. File system resource. This is the resource implementation for java.io.file handle. It also supports java.nio.path.path but performs all operations via java.nio.file.files handle. Path resource. This is the resource implementation for java.nio.path.path handles. It also implements the writable resource interface. Servlet context resource. This is the resource implementation for servlet context that interprets the relative paths within the 11th web application's root directory. Input stream resource. This is the resource implementation for a given input stream. This is the descriptor for an already opened resource. Do not use it if you need to read the input stream multiple times. Byte array resource. This is the resource implementation for a given byte array. Resource loader interface. The resource loader interface will be implemented by classes which will load resources. All application context implements this interface. When you call getResource method on application context without specifying the prefix, it will create a resource type that is specific to particular application context. That is, ClassPath XML application context creates a ClassPath resource, while the same method on file system XML application context creates a file system resource. Also, we can force creation of a particular type of resource in this method by specifying the appropriate prefix. Prefix classpath colon loads from classpath. Prefix file colon loads as URL from file system. Prefix HTTPS loads as URL. Resource pattern resolver interface. It is a sub interface of the resource loader interface which resolves the and style path pattern. For this, pattern classpath star colon slash config slash beans.xml resolves multiple files residing in different jar files and different directories with the same path in all class path locations. Path matching resource pattern resolver implementation can be used in standalone applications. Resource loader aware interface. It identifies a component that expects to be provided with resource loader. Since application context also implements resource loader interface, Beans can implement application context aware interface and use application context to load resources. Resource loader can also be auto-whiled in a bean. To make use of wildcard entries in path, use resource pattern resolver interface. We can also create a bean with resource property, and in the bean definition, we can assign string values to that property. Application context will convert string value to resource objects. In annotation-based configuration, value annotation can be used to fetch path string value, and the application context will convert it to resource object. The validator and data binder, which is included in validation package, is primarily used in the web layer. Validator interface is used to validate objects. It uses an errors object for reporting validation failures. It includes these methods. Supports of class method used to check whether this validator validates instances of supplied class. Validate of object, comma, arg.springframework.validation.errors. Validates the object and reports validation failure if any to supplied errors object. Here is an example of validator implementation. Static validation utils class reject if empty method rejects the name property if it is null or empty. For example, we have a person class and its corresponding validator. In the driver method, we are creating an instance of person validator class and we invoke validate object passing the instance of person class, which returns a errors object. If the object has validation errors, it will not throw any exception, but when we call fail on error method on the errors object, then it will throw an exception when the person object has validation errors. Bean wrapper. Bean wrapper interface and its bean wrapper IMPL implementation can be used to set and get property values of its wrapped bean instance. The bean class has to follow Java Beans naming convention for getter and setter methods. For example, here bean wrapper is used to set and get the property values of the wrapped person instance. Custom property editor. Property editor is used by Spring to convert string value to a particular type variable. A date format string can be converted to date objects. Some of the property editor that come with Spring are file editor, which converts string to class object, custom date editor for converting customizable date format string to java.util.date object, etc. We can also register a custom property editor. Property editor is created by extending the property editor support class and it is registered with custom editor configurer in the beans.xml file. Property editor registrar can be used for registering custom property editor which work in conjunction with property registry. It is used to register a group of property editors. We can define a custom property editor registrar, extending property editor registrar, and overriding register custom editors method. The method receives a property editor registry instance using which we can register the custom property editor. For example, we have three classes: exotic type depends on exotic type, which has one property of type exotic type, and exotic type editor, which implements property support editor. It overrides the setAsText method and provides the logic to convert string value to exotic type value, which will be set into a depends on exotic type instance while being creation. Now consider the bean definition XML, which defines depends on exotic type bean. It also includes a bean definition for custom editor configurer, in which we add a map entry for exotic type editor. So when we create a depends on exotic type bean and pass a value for its exotic type property, our registered editor will be used. Instead of registering the editor in XML file, we can register programmatically by providing an implementation of property editor registrar and overriding the method register custom editors. In this method implementation, we can register our editors. In the bean definition XML, we have to provide a bean definition for custom editor configurer and create a list entry for our property editor registrar implementation. Converters. Spring's core.convert package provides a general type conversion system. It can be used as an alternative to property editor. Convert of S, T interface can be used to implement the custom converters, where S is the type of the source object and T is the type of target object. We have to implement the T convert of S method and provide conversion logic. Then this custom converter can be registered in bean definition. We have to include our custom converter in the converters set. To use the conversion programmatically, we can use an auto-wide field instance of type conversion service. We can call the convert method with source object and target type to get the target object. Here, we can consider the previous example. Instead of using property editor, we can use converter for the same purpose. Exotic type converter implements converter, providing string and exotic type for generics, which represents source and target respectively. The convert method of conversion service accepts two arguments, source value and target type. This is the bean definition for a custom converter example. Here we want to create a bean definition for conversion service factory bean and add an entry for our converter. Spring Expression Language. It supports querying and manipulating object graphs at runtime. For example, to use this programmatically, we have to create an instance of expression parser and parse expression string using its parse expression method. The result of the expression can be obtained by calling the getValue method on the returned expression instance. Here, the parse expression and getValue may throw parse exception and evaluation exception respectively. SPEL supports various functionalities. All classes and interfaces are located inside org.springframework.expression package and its subpackage spel.support. SPEL can be used to access bean properties inside value annotation. For example, here we are creating a new person instance and setting its name property. Now We are creating an instance of SPL expression and we parse the expression. In the get value method, we pass the person instance and we are typecasting to corresponding type. Aspect oriented programming. The unit of modularity in object oriented programming is class, whereas in aspect oriented programming is aspects. These are the terms used in aspect oriented programming. Aspect, a modularization of concern that cuts across multiple classes. Join point, a point during the execution of the program, a method or exception handling. Advice, action taken by aspect at particular join point. Different type of advice available are before, around and after. Spring models aspects as an interceptor and maintains a chain of interceptor around the join point. Point cut, a predicate that matches join points. Advice is associated with point cut and runs at any join point represented by point cut. For example, execution of a method with a certain name. Introduction. Declaration of additional methods or fields on behalf of a type. Target object. An object being advised by one or more aspects, also referred to as advised objects. AOP proxy. An object created by the AOP framework in order to implement the aspect contracts. Weaving, linking aspects with other application types or objects to create an advised object. Spring uses following type of advice. Before advice. Advice that runs before a join point and it can prevent the flow proceeding to join point by throwing an exception. After returning advice. Advice to be run after normal execution of join point. After throwing advice. Advice to be run if the method exits by throwing an exception. After advice. Advice to be run regardless of method exits. Around advice. Advice that surrounds the join point. Around advice can perform custom behavior before and after join point. It is also responsible for choosing whether to proceed or skip advised method execution by returning its own return value or throwing an exception. Point cuts enable advice to be targeted independently of the object-oriented hierarchy. Spring supports only method execution join points. Spring AOP functionality is normally used with Spring IOC containers. Aspects are configured by using normal bean definition syntax. We can also use aspect J annotation to use aspects. Aspect J support. We can create aspects as regular Java class annotated with aspect J annotation. To use aspect J aspects, we need to enable Spring support for configuring Spring AOP. Spring intercepts the method invocation in an advised bean object by creating a proxy to the bean. Enable aspect J auto proxy annotation can be used to enable this feature. To declare an aspect, we need to annotate bean classes with aspect annotation along with component annotation for Spring to auto detect. Declaring point cut. A point cut declaration has two parts, a signature comprising a name and any parameters, and a point cut expression, where point cut signature is method definition and point cut expression is provided by point cut annotation. A method serving as a point cut signature should have void return type. Following example defines a point cut named any old transfer that matches any execution of any method named transfer. Point cut designators. Following are the aspect J point cut designators to be used in point cut expressions. Execution. For matching method execution join points. Format of execution type pattern is given here. The pattern that is marked with question mark at the end are optional. The returning type pattern determines what the return type of the method must be in order for the join point to be matched. Star is most often used for this pattern and it matches any return type. The name pattern matches the method name. We can use star wildcard as all or part of a name pattern. If declaring type pattern is specified, we should join this pattern with name pattern with a dot. Empty parenthesis matches methods that do not take any parameters, where parenthesis with two dots inside matches any number of parameters. Parenthesis with a star inside match method with any type of single argument. While parenthesis with the star and string must match the method with first argument as any type and second argument as string type. For example, this is the point cut expression to select all execution of public methods. Within limits join points with certain types. For example, this point cut expression matches any join point inside com.xml.service package. This limits matching to join points where the bean reference, that is the proxy, is an instance of the given type. Here the point cut expression matches all methods from the proxy which implements account service. Target limits matching to join points where the target object, that is the object being proxied, is an instance of the given type. Here, the point cut expression matches all methods from the target which implements account service. Args limits matching to joint points where the arguments are instances of the given types. Args can be used in point cut expression to receive method arguments. It also ensures that method with specified argument type is matched. Here, the point cut expression matches all methods which accepts one argument of type java.io.serializable. At the rate target, where the class of executing object has an annotation of given type. This point cut expression matches where the target object has a transactional annotation. At the rate arg, where the runtime type of the actual arguments have an annotation of the given type. This point cut expression matches all joint points with single argument of type com.xml.classified. At the rate within types that have the given annotation. The point cut expression matches any join point where the type of the target object is annotated with transactional. At the rate annotation, subject of the join point has the given annotation. This point cut expression matches all join points where the executing method has a transactional annotation. Bean limits to bean with particular name. We can combine point cut expressions by and, or, and negation operator. We can refer to point cut expressions by name. For example, first point cut expression matches execution of any public method. Second matches if it is a trading module. First two expressions are combined in the third. The visibility used in the method definitions affect the reference of point cuts. Declaring advice. We can declare before advice using before annotation and assign the point cut expression as its value. After advice runs after the advised method execution. After returning annotation can be used to declare after returning advice. We can access the returned value of the advised method by accessing values through returning attribute and using it in method parameter. It also restricts matching to only methods that return a specific type. After throwing annotation can be used to match method execution which exits by throwing exceptions. We can use the throwing attribute to match the method which throws a particular type of exception and the thrown exception object will be available inside the method. After annotation. Advice method runs after matched method execution exits normally or by throwing an exception. Around annotation. Advice method return type should be object and its first argument should be of type proceeding join point. Within the body of the advice, we must call proceed on proceeding join point in order for the underlying method to run. There are two variants of proceed method. When proceed is called without any arguments, the underlying method is called with default arguments. We can also pass arguments by calling proceed of object array. Here is the class which uses all type of advice. Determining parameter names. Parameter binding in advice invocations relies on matching the names in point cut expression to parameter names declared in advice and point cut methods. Spring AOP uses some implementation of parameter name discoverer to determine parameter names. Aspect J annotation parameter name discoverer uses parameter names that have been explicitly specified by the user via the argnames attribute. Kotlin reflection parameter name discoverer uses Kotlin reflection APIs. Standard reflection parameter name discoverer uses java.lang.reflect.parameter API to determine parameter name. Aspect J advice parameter name discoverer deduces parameter name from point cut expression, returning and throwing classes. Examples of arg names. Here, target bean and annotation is selected through arg names. By using arg names, we add additional conditions to point cut expression. Only methods that have the first argument conform to object type and which has a music annotation is matched. If the first argument is of type join point or proceeding join point of join point.static part, the name of the parameter is not required in arg names. Advice ordering. If there are multiple pieces of advice defined for the same join point, then these advice methods are executed according to their precedence. The precedence from highest to lowest is around, before, after returning, and after throwing. Aspect class can implement ordered interface or it can be annotated with ordered annotation to assign precedence. Introductions. Introductions enable an aspect to declare the advised objects implement a given interface and to provide an implementation of that interface on behalf of those objects. We can create an introduction by using the declare parents annotation. This annotation is used to declare that matching types have a new parent. For example, to track usage of beans, we can create an interface usage tracked and provide an implementation default usage tracked. We create a mixin using declaring parents annotation and provide interface and implementation class fully qualified names. Now all the bean proxy instance in com.xml.service package will implement usage tracked and implementation will be default usage tracked. In the advice method, we can access the usage tracked bean proxy instance increment count method. Schema based AOP support. All annotation based configurations can be done in XML configuration also. All point cut aspects and advisor elements must be placed inside AOP colon config element. Declare an aspect using AOP colon aspect element with its ref attribute value set as bean ID. Named point cut can be defined using AOP colon point cut. To declare a point cut for an aspect, declare point cut element inside aspect element. This object reference can be obtained using this in point cut expression. The method must declare a corresponding parameter. And or not keywords can be used instead of and or not operators. Named point cut can be referenced with point cut if ref attribute in the AOP colon before element. For inline point cut, use point cut attribute. Five types of advice can be configured using AOP colon before, AOP colon after hyphen returning, AOP colon after hyphen throwing, AOP colon after, AOP colon around. Method attribute identifies the method with the same name in aspect. Returning attribute can be used in AOP colon after hyphen returning element to receive the return value. To get the thrown exception in after throwing advice, we have configured the throwing attribute in its element. Argument names can be specified using arg-names attribute. Order can be specified using order attribute in AOP colon aspect. To make an introduction, create AOP colon declare hyphen parent. Property source. Property source annotation can be used to add property source to a container. Then properties can be accessed in a bin using environment. For example, here we have provided a property source from app.properties in class path and the property app.name is accessed from autovide environment instance. Bean post processor. Bean post processor defines callback methods that you can implement to provide your own instantiation logic, dependency resolution logic, and so forth. If we want to implement some custom logic after Spring finishes with instantiation, configuring, and initializing a bean, you can plug in one or more custom bean post processor implementations. Its order of execution can be controlled by setting order property by implementing ordered interface. When bean post processor is registered with the container, for each bean created through the container, the bean post processor implementation gets a callback before container initialization methods such as initialization bean dot after property set or init method are called and after bean initialization callback. The post processor can take action with a bean instance. Bean post processor can be deployed in application context like any other bean. Application context automatically detects the beans that implement bean post processor and registers as post processors. Bean post processor can also be registered programmatically. When bean post processors are registered programmatically, do not respect the ordered interface. It depends on the order in which it is registered. Programmatically registered bean post processors are executed before auto-detected bean post processor. Spring's auto-wired bean post processor are used to set values to the auto-wired fields. For example, here instantiation tracking bean post processor implements bean post processor. In the post process before initialization method, it just returns the bean instance. In post process after initialization, it is just printing a message to the console. These two methods, post process before initialization and post process after initialization, are called before and after bean instance initialization process. Bean post processor implementations can also implement ordered interface to provide the order of the execution. Bean factory post processor. Bean factory post processor is used for post processing configuration metadata rather than bean instances. The application context first create instances of bean factory post processor and it is executed before creating any bean instances. It can implement an ordered interface to provide the order of execution. For example, configuration metadata check implements bean factory post processor and overrides post process bean factory. In this method, we get the instance of configurable listable bean factory to modify the configurations of bean definition metadata. Thanks. If you find this video valuable, you may share it with others. If there are mistakes, please mention them in the comment section.